Hi, my name's Alex Hines. I'm a tutor with the School of Computer Science and Engineering, and today I'm going to talk to you about ADTs, or Abstract Data Types. I'm going to talk about it in 3 different parts, and this video largely is going to focus on from the use perspective rather than the implementation point of view, and I'm going to try and keep it as broad as possible. We're going to look at the ADTs that you've already seen in C already at this point in your C learning, and we're going to look at file stars. We're going to look at file pointers, if you like. We're going to look at the conceptual definition of what actually makes an ADT, and maybe some guidance on what actually represents. We're going to look at this user versus implementer contract as part of that. And then we're going to look at a concrete example with respect to a set, which you've probably hopefully seen in mathematics, at least in Maths 1A, and if not, probably at high school. In the next few videos after that, we're going to look at some other concrete examples in terms of queues, stacks, and binary search trees. But this is hopefully going to be the introduction which will get you there so that when you see those videos, it'll make a whole lot more sense. Okay, so the ADTs that you've already seen, potentially without even knowing it, are something like a file star. A classic example. You don't know anything about the file pointer in terms of the way you in terms of the implementation, I should say, even though you use it all the time. For example, if we were going to use something like fopen, and we put that in here, and we have a path to file, and we open it for reading, and we assign that to FP. Okay, well, after this operation, which I'm sure you've used yourself many times, FP now has a whole lot more meaning than simply a pointer. It's got a whole lot of information associated with it. Now, we don't know how that's happened. We just know that it has happened. It's important in some respects to think of this thing as the stuff that we need to know versus the stuff that we actually, the stuff that's more complicated and is kept apart from us. So FP is potentially made up of a whole lot of complicated interactions with files in the operating system. We don't need to know any of that. All we need to know is FP now represents our file in our program. It allows us to do something like, in the next step, fgets, and we could have an array, which we'll call array, and let's say it's size 10, so we're just going to read for 10, and we're going to read from our file pointer. Okay, so again, fgets, not fget. Fgets, all it does is it's reading from our file pointer in some way, again, which we don't know anything about as a user, and it's reading into our array. So what I'm trying to instill is something quite crazy is happening, and that is we have our file on our operating system. Let's call it file. It's nice and simple. Goes into our little circle, which is called fopen. And some magic happens, as far as we're concerned as a user. It's not quite magic, although it seems like it. And out comes our file pointer with a new meaning, because before it was just a pointer, could have been anything. Now it actually is associated with this file up here. Okay, cool. Hopefully that makes some sense, but maybe we should now think about things in more of a stronger sense in terms of this user versus implementer. I've been really trying to say this as much as possible, but as we've said from our user perspective, we don't know what's going on. But the implementer, they know all sorts of complicated things that are going on under the hood. The difference is the way this is separated in terms of this, I suppose, contract, if you like, between the user and implementer is we just have to agree on the middleman, and the middleman is this functionality. So fopen, we know that we're getting a file out of it. But it could be any sort of functionality. It could be, fclose. It could be for a queue or a set. It could be something like add an item to the set, append a linked list. The functionality, as long as the functionality behaves the same for the user, it doesn't really matter what's going on under the hood. Okay, hopefully that's made some sense, but I'm going to go a little bit deeper now and talk about a real concrete example, so it should harden things a bit for you. I'm going to talk about a set. So I don't want to get all mathsy, but just to remind everyone in terms of what a set is and how that works before we actually go into some code, just to remind everyone, in case you do need the refresher, say we have two sets. Generally the set notation looks something like this, and let's say this set contains 0 and 1, and set 2 contains 1 and 2. Remember, sets can only contain unique items, so there's no duplicates, etc. Order doesn't matter. There's some other cases, but we don't really need to worry about that for now. We can see, well, 0 is an element of A, but for example, 2 is not an element of A. It is, however, 2 is an element of B. Okay, cool. That's some basic sort of set operations. If we wanted to do some adding, then we could add one of these items to another set, and potentially we could remove. We could also do intersections. So, for example, A, B would yield us our common element. So it would be 1 in this case. So we would yield a set which looks like, well, simply this. And that would be our new set. And then I guess if you want to really stretch it out, down here we could add a union B, which is sort of, I suppose, the last obvious set operation. And in this case we would have 0, 1, 2. Not that hard, Alex. Cool. Okay, that's sort of like how sets work. So let's now go onto the computer and sort of make some of this mathsy stuff into a concrete interface where we can treat it as an ADT and start to use it, and how we'd actually build that and think about it. So we've already talked a lot about sets from a conceptual point of view. Let's start talking about sets from a C point of view, and particularly from a user's point of view, about how we want to use a set. And common to all ADTs in this aspect is creating this .h file interface. And I've got an H file set up, which I've just put a single line in, which is _set pointer set. So it's creating our set pointer. The rest is up to us in terms of how we want it to look and what sort of functionality we want to give it. Now, some very, very common functionality that pretty much all ADTs will have. It doesn't have, these aren't really unique to a set, but we're probably going to have something like a create a new instance. So new set, void, and that's going to assign some memory, similar to what we did with fopen, and it's going to create a new instance of our set. It's going to return a new set. Okay, cool. So new set. That is function number 1. And I probably should put comments in here so everyone understands the interface. So creates a new set. Cool, great. Now, again, common to almost all ADTs, it's probably going to be add an item. I mean, that's very, very, very common. Doesn't matter if you're doing a linked list, a queue, or whatever. So we'll probably have something like add an item. And for the purposes of keeping things as simple as possible for our set, let's just use an integer as our data type that we're going to be adding to our set. Keeps things fairly simple. So add, fairly simple name, and we need to give it our set that we're going to be adding to. Okay, cool. And also our integer that we want to add. So let's just call it n, and that just is going to add an n integer to our set s. Okay, cool. Again, another one which is fairly common is going to be remove or discard, because I think remove is actually a name clash in some, or it can be a name clash. We're going to use discard. So we're going to use discard set s, and we're going to give it our another integer. So that's going to remove n if it exists from set s. Okay, cool. And again, these first three are very common. They're very common to almost all implementations. You'll be using add, discard, and new creation. One final one in terms of very common to all ADTs is, of course, delete our ADT. So delete set in this case, set s, and that will literally do all we need it to do. Okay, cool. Delete a set. Now we're some of the way there. We've got some universal functionality. Now we want to add a bit of flavor to our set, things that only a set would probably have. So maybe we'll add size would be again, this is sort of universal, but we'll put it in maybe a bit more of a flavory type thing. So size of our set returns an int, and that will returns how many elements. Cool. And we're also going to want probably, well, let's do something which is definitively a set operation. That's going to be intersection. So intersection of set, and it will return a set, and it takes in two sets, set S and set O, or actually maybe we should make it really obvious, like the things we did on the board, set A and set B. Cool. And that will return a set. Cool. And one final thing which I've kind of put on some of my implementation, so I'll just put it in here just so I don't create any issues. Well, actually, sorry, two final things. We're going to have contains, so it returns a int, although it could really be a boolean, but C doesn't have that functionality. So set S, int n, and it's going to return true or false. And finally, maybe you want to see all the items in our set, so I'm going to have a print set, just for the purposes of just seeing that it is actually working. Probably wouldn't necessarily have this in our ADT interface. It could just be a debugging one, but I'll put it in here just to sort of give you a better sense of something that the user may want. They may want to use a print set and see what's in there, so reasonable. Okay, so this is sort of these are all the functions that we want to use in our set, and then just to give you an idea of how we would use all of these functions, I'm just going to quickly run a faux program, which isn't real. It won't be totally real C, but let's just say this is how we'd use it. So we do something like that. Set S equals new set. Okay, cool. We would then, and we would make sure that if we were going to use this in real C, we would be include set.h, which is our fancy interface that we've just designed. So set S, that'll give us a new set. If we want to go something like add S1, that should add the number 1. And then if we wanted to, well, if we want to see what size at this point of our S, this should return 1. And I don't know, we could discard 1, and from S, and that should now make our set look like this, just simple, just empty set. And then maybe, I don't know, I guess we could verify that as well. Size of S. Now this should just return 0. And what else do we want to do? Well, this is sort of just very basic. Then maybe we delete our set, so we'd delete set S. So we finish using it. We didn't really do much with it, but this sort of just gives you a real basic idea of the functions that we've designed, the way we would call them in our C file, and further future use cases. But for all intents and purposes, all we've been given here is a set pointer. It gets allocated memory. We add some items to it, but all of these operations, we don't know anything about how they're going on. We just assume that they're going on. So as long as that behavior, as I said in the video before, is consistent, that's all we need to know. So hopefully that has made some sense with respect to how we use a set and in terms of the interface that we would create and how then we would go about some basic use cases in C. In the next video, we're going to look at things from an implementer's point of view. So before we get there, just underline what we've looked at. We've looked at ADTs that we've already seen, like file pointers. We've looked at the user versus implementer contract, how these two interact, and what needs to happen in terms of the user seeing only a certain element and the implementer then being able to extract and do whatever they want underneath without the behavior changing. The behavior has to be constant. And finally, then we looked at a set. I'm going to put all this code up there so you can use and fiddle around with it if you want to, but we can look at in much, much more detail in the next video, which we'll look at implementation.